All right, this video is on lesson 5.1, which is called Model Factors, and it's on page 279 in your Go Math book. So we have a new vocabulary word this chapter, and that's the factor we have here. So a factor is a number multiplied by another number to find a product. You guys have been using factors the entire time that you've been doing multiplication. Every whole number greater than 1 has at least two factors, that number and 1. So if we look at 18, one way that we can get 18 is by doing 1 times 18. So 1 and 18 are both factors of 18. You could also do 2 times 9 to get 18. So 2 and 9 are also factors of 18. Just like 7 and 1 are factors of 7, and 1 and 342 are both factors of 342. So down here, if we look at the activity, we want to use 24 tiles to make as many different arrays as we can. So basically, we're finding all the factors, all the different ways that we can multiply together to get to 24. So I've drawn them all out here for us. So we have 2 and 12 was done for us, so 2 and 12. And then we can think of 1 times 24, 3 times 8, and 4 times 6. So the factors would be 1 and 24, 3 and 8, 4 and 6, 2 and 12. So if we list the factors of 24 from least to greatest, we would have 1, 2, 3, 4, 6, 8, 12, and 24, meaning all these numbers I can multiply in some way to get to 24. So now I want to show you something called a factor rainbow. A factor rainbow helps you find all of the different factors of a number. So when we do our factor rainbow, if I want to find all of the numbers for 24, I would always start with 1. So I can always do 1 times something to get a number. So in our rainbow up here, we're shooting for 24. So I would have 1 times 24. Then I would ask myself, does 2 go into 24? Well, I know it does. So I'm going to write 2 there and 12 there. Now I'll go to my next number, 3. Does 3 go into 24? Yes, it does. 3 times 8. And then I'll say, does 4 go into 24? No. 4 times 6. Now the only other number I have in between 4 and 6 is 5. And 5 does not go into 24. So I know that my rainbow is complete once my rainbow has come back to the middle and I have no other numbers in between. And then the rainbow part comes in because I can connect my factor pairs to each other to make it look like a rainbow. So now we're going to look at number 2 and 3 on page 280. And instead of using tiles like we did in class, we're going to use the factor rainbow strategy in the video. So if I cover up my 5 here, so the way that we'd find a factor rainbow for 5 is we'd always start with 1, and we know that 1 times 5 equals 5. Now we go to 2. Does 2 go into 5? It does not. So 3. Does 3 go into 5? Also not. Does 4 go into 5? No. And there are no other numbers in between 1 and 5, which means that the only factors that 5 has are 1 and 5. And we're going to get that into the next lesson, but that means that this is a prime number. So that's a sneak vocabulary word for our next lesson. If we look at number 3, we're trying to find all of the factors for 20. So we're going to put 20 up in our cloud here. And again, we're going to start with 1, and we know that 1 times 20 equals 20. Our next number is 2, so 2 does go into 20. I know that's even, so 2 times 10 would be 20. 3 does not go into 20. 4, however, does go into 20. 4 times 5. And now there's no other numbers in between 4 and 5, which means I'm done with my rainbow. I've found all of the factors, so I can connect my rainbow. So where our 5 up here only had 2 factors, our number 20 down here has 6 factors. So the sneak vocabulary word for this one is that this means that this is a composite number, or more than 2 factors. Now we're looking at question number 9 on page 281. It says Pablo is using 36 tiles to make a patio. Can he arrange the tiles in another way and show the same factors? So over here on our picture, Pablo's patio is currently arranged in 4 tiles of 9. So he's using all 36 because 4 times 9 is 36. We want to know if there's other ways to find 36, so other factors of 36. So see if there's any other possibilities of how he could make his patio. So what I've done is I've drawn a factor rainbow so that we could look at some of the different possibilities here. So we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So Pablo has a lot of different choices for how he wants to arrange his patio because all of these different factor pairs make 36. So if we look down, we can say Pablo can arrange the tiles in another way. He could also make 3 rows of 12 and show the same factors of 36. Now I could have put 4 rows of 9 here, and I could also done 3 or 12 rows of 3 or 2 rows of 18. So any different option would have worked. Those are just the ones that I selected. So now if we continue on to number 10, because it goes right along with this question, it says how many different rectangular arrays can Pablo make with all 36 tiles? So none of the arrays show the same factors. So it's basically asking us how many different ways can we make a patio? So if we're gonna count our factor pairs, one of the ways that we can do that is count our rainbow lines. So we have 1, 2, 3, 4, 5 factor pairs, or 6 times 6, 4 times 9, 3 times 12, 2 times 18, and 1 times 36. So there are 5 factor pairs, so he could make 5 different arrangements. Question 12 says, Jean spent $16 on new t-shirts. If each shirt cost the same whole dollar amount, how many could she have bought? So again, what we're gonna wanna do is we're gonna wanna make a factor rainbow. So for 16, I made the factor rainbow over here. We have 1 times 16, 2 times 8, and 4 times 4. So that means we have a couple of different options for how many t-shirts she could have bought, and I've written them all down here. Jean could have bought 16 t-shirts for $1. That would have been a great deal. She could have bought 8 t-shirts for $2, $4 on each t-shirt if she bought 4 t-shirts, or she could have bought 2 t-shirts for $8. Now I didn't put $16 on one t-shirt because it says she bought t-shirts, more than one. So we want to look at the options for more than one. So she could have bought 16 for $1, 8 for $2 each, 4 for $4 each, or 2 for $8. Right, question number 13 on page 282 says Carmen has 18 connecting cubes. She wants to model a house shaped like a rectangle. If the model has a height of 1 connecting cube, how many different ways can Carmen model the house using all 18 connecting cubes and none of the models show the same side lengths? So again, this is asking us how many different ways can I arrange 18 into a rectangle? Meaning I'm going to want to find my factor pairs. So I'm going to do 1 times 18, 2 times 9, 3 times 6. Now 4 does not go into 18, 5 does not go into 18, and now I'm at 6, so there's no other numbers in between, so I am done. So 3 times 6, 2 times 9, and 1 times 18. So there are 3 different factor pairs, which means that she can arrange her house in 3 different models. That's question number 14. Says Sarah was organizing vocabulary words using index cards. She arranged 40 index cards in the shape of a rectangle on a poster. For 14A through 14E, choose yes or no to tell whether a possible arrangement of cards is shown. So basically we want to know, do these multiply together to equal 40? Are these numbers both factors of 40? So 4 times 10 equals 40, so that means she could do this arrangement. 6 times 8 equals 48, so that would be a no. 20 times 2 equals 40, so that would be a yes. 40 times 1 equals 40, so that would be a yes. And 35 times 5, my goodness, 35 times 5 would be 175. That's definitely a no. So that's how you would solve that problem.